So we have seen basic scans, ping scan, and stealth scan. So let's go ahead and try to find out what are the various versions of different services running on that particular target. So let's see the output first, and then we will decide what exactly is this thing showing. So Nmap SV, V stands for version. Now I will see, and you will be able to compare the outputs. What exactly I'm talking about. It will take some time because now it's not only showing the ports but also the versions associated with those ports. As you can see, I hope you are able to perform this. See, the version of that particular service is also highlighted over here. It's very important because in Linux, specifically in Linux, different versions might have different dependencies. So the Kali Linux machine I am running right now might turn totally obsolete if there is a version change. So I have to keep a track of the version changes, and accordingly I have to install all the dependencies. So those who are using Ubuntu, those who are using Linux might be totally aware that a single version change might causing a lot of changes in the actual output. So this is very much important because the versions are really very important whenever we are trying to launch an attack. Right? So for FTP, in the previous scan, only these 3 columns were there. But in this scan, we have this 4th additional column, that is the version. I hope you are able to run this. So along with the services, we also now have the versions associated with those services. So this was the service detection scan, that is a version scanning. Now let's go ahead with the next scan, that is OS scanning. So what exactly OS scanning is, as the name suggests, if we run this with the -O payload or -O option, it will let me know what is the OS which is running on that port, on that host. So let's see. Again, it requires root privileges, sudo. Fine. Now you see this MAC address of that particular host. In my case, it's running on virtual machine, so it's a MAC address of that virtual machine which I'm running right now. It is running Linux 2.6.x. As you saw while installation, we had selected Linux because this is built on top of Linux, right? So this is the OS which is running on that particular Metasploitable VM. That is Linux, and the kernel version is 2.6. We are capturing the information, as much information as possible. So this is OS scanning. Now, if you want to combine 2 or 3 scans together, you can do that. For example, I want -O, and if I want -SV version along with the host, operating system, they will be mentioned together. We can do that. We can club or we can merge 2 or 3 different kinds of scans together. It will take time, obviously, but it will give the results. As you can see, the versions are also there, versions of the services along with the operating system as well. Yeah. So this was one of those scans. Now let's see, there's something called as aggressive scanning. Now it is exactly opposite of stealth scanning. Stealth scanning made sure that your identity is not revealed. But as I had discussed earlier also, that if you keep on sending messages more than what it is supposed to send in a particular period of time, it might reveal your identity. But what is there on the other hand as a trade-off? You can get more amount of information from that target system if you go with aggressive scanning. But the only drawback is you may reveal your identity. So there is a trade-off, there is a catch between what amount of information you would want to have from that target and whether you would like to keep your identity hidden or it is okay if it's made public. So based on that, this particular scan is done. Actually, what happens, there is a limit of messages that can be sent in a particular period of time. If you cross that, you might leave some traces on the server side, and as a result, your identity might be revealed. And that's what is happening over here. Instead of -O, if I go with -A, it stands for aggressive scanning. It will keep on sending a lot of requests, and as a result, the server might identify that there is something happening in the network. So let's wait for the result. As you can see, there is some additional information and a lot of useful information. I will show you what exactly I got from this scan. It's a detailed output. As you can see, it's a complete output. In the previous scans, we only came to know the port number, the service, and the OS at the end. But over here, the port number details are also mentioned over here. As you can see, it is connected to so and so. The encoding type is ASCII. No session bandwidth limit. Session timeout in seconds is 300. 300 is the session timeout. So this is a very critical information. Let me tell you, the session timeout for FTP server in this case is 300 seconds. So I know that after 300 seconds, my ongoing session will expire. So what I can do is, if I'm an attacker, I will make the request in such a way that after every 299 seconds, the request is fired again. The FTP attack request or attack packet or payload is fired again. Otherwise, what will happen? I will fire the payload, exploit the attack, and after 300 seconds, it might expire and the attack will not be valid. So over here, what I will do is, if I'm an attacker, after every 299th second or 298 second, I will relaunch that particular payload or exploit so that my attack keeps on going on. It's just an example. You can visualize anything, but it's just an example that these informations come really very handy if we perform the aggressive scanning. As you can see, FTP, TCP. TCP is secure shell. Secure shell. This is nothing but the host key. As you can see, the algorithm which is used to encrypt this or create the hash, it is mentioned over here. Digital signature algorithm is being used, which is of size 1024 bits. Similarly, RSA algorithm is used, which is having size of 2048 bits. This is very crucial from a network security point of view. You have this hash values. You can try to break these hash values using some decrypt tools, hash tools. Again, if I see this port number 25 TCP, it is using SSL version 2. And these are the ciphers which are used to encrypt the messages. So you have got a lot of information now. Fine. Now what we'll do is we'll actually start scanning a particular port. It's very simple task. You simply need to target a port. For example, we came to know that these many ports are open. So if I want to target a specific port, I would launch a specific attack for that port. Just imagine I want to launch an attack on port 80. So I will have to run this command, nmap -p. -p stands for the port number. Suppose port 80 is what I'm targeting. Then 192, sorry, nmap -p. Then port number 80. Then 192.168.0.159 and press enter. See, this is simply a specific port that we are targeting. It's quite faster as compared to the entire scan. What we did, what we saw in the previous few scans was, it was not focusing on a particular port. It was focusing on the entire 1,000 well-known ports. But over here, we are focusing only on a single port to check whether it is open or not. So let's move ahead and let's see what's next. Scanning from a file, again, it's a quite simple task. What you need to do is, you need to, for example, if you want to scan multiple hosts together, you're not having a single host, but you want to target multiple hosts. So for that, you can create a text file which contains the list of those IP addresses. I will quickly show you how to do that. In your Kali machine, click on right-click on the desktop, go to desktop and create an empty file. Any name. In my case, I am giving it the same name so that I can simply run the command. I'm creating a text file. In my case, I'm having only a single target. But in your case, you might be having multiple targets. So I'm simply writing some email addresses, 192.168.0.159. This is my actual intended target. Suppose 192.168.3.2. And suppose 192.111.112.3.6 or 2.5. Fine. Suppose this is my list of IP addresses which I want to scan. So far, we have seen that we can separate the hosts by spaces. But to make it cleaner, to make it look cleaner, we can use something like this. IL will be used to take the input from the desktop. So go to that location where the file is present, go to properties and copy the path. This is my path. So I will copy this, go over here, paste the clipboard, followed by file name. File name is input ips.txt. So it will do the same task as running the scan with multiple IP addresses separated by spaces. See, Nmap done. 3 IP addresses are scanned, out of which only one host is up, which I know is the target IP address, that is 159. The rest all will not reply to the communication process. So let's go ahead and let's see something called as verbosity or verbose. Now, verbose is nothing but displaying the output line by line in simple terms. So sometimes it happens that the attacker wants output for each particular step, for each line. So in that case, the attacker can make use of something called as verbose. I will simply use the previous command only, and along with it, I will write -v. -v stands for verbose. If I write -v, now see how the output differs. Press enter. See, now it is specifying what exactly are we doing in each line. Just have a look. Scanning 3 hosts, completing ping scan, completed parallel DNS resolution, Nmap report, initializing the connect scan, and so on, discovered port, and so on. So it is specifying the output of each and every process that is done through this particular command. I hope you got the understanding of what exactly verbose means. I'll share this PPT with you so that you can practice the various commands.